Hello, my name is Jake, and in this video we're going to take a look at modeling the Antoine equation for water in Python and comparing that model to experimental data points to see how well it fits, how well it represents the known values of the vapor pressure of water at given temperatures. So here I have the Wikipedia page open for the Antoine equation, and this is an equation that calculates, so it models the relationship between the vapor pressure and temperature of any pure component and has these constants specific to each given component to perform these calculations. So as you can see here, the equation reads log base 10 of the vapor pressure is equal to constants A minus B divided by the quantity C plus the temperature. And the units can vary within this equation. As you can see here, this table is displaying the temperature in Kelvin and the pressure in millimeters mercury. And there's a range of where these equations hold true with the given coefficients. So at higher temperatures, the coefficients will increase. And this is right at the boiling point of water where that shift occurs. And again, right at the boiling point of ethanol where the shift in the coefficients will occur. And then on the Dortmund databank, which is a subscription service for thermophysical properties of compounds, this is the page for the water vapor pressure data. And as you can see here, we have a table containing a range of temperatures in degrees Kelvin and the corresponding vapor pressures at those temperatures measured in kilopascals. And back to the Antoine equation, you can see down here they convert the same equation from units of Celsius and millimeters mercury to Kelvin and pascals, which corresponds nicely with this data table that we're getting from Dortmund. And the equation is unchanged. We still have the log base 10 of our pressure is equal to A, B, and C from the conversions right above. And they end up calculating the log base 10 of this pressure. So this is Google Colaboratory, which is an open source Python coding website. It'll allow us to create our code and run it, check it, get it to work. And then to pull this data from the Dortmund databank, it would be a tedious task and we would be opening ourselves up to operating error, copying each cell here and transposing it into our Python code. So rather than doing it that way, we're going to use the XPath function, which is a form of regular expressions, and this will pull all of the data that all of our targeted data, the data of interest from these two columns into our Python code and save them as variables to later be used in our equations, and we can plot them, we will plot them, and then compare the data here to our model of the Antoine equation. You can also see there's a bunch of additional information which we do not need. So our regular expression must be specific to this data. It must be a well-written regular expression to pull the data we want and exclude the data that we don't want. All right. So to begin with, we add our imports. These allow us, they're pre-built Python coding libraries that allow us to run a variety of functions without having to include the entire code of the function in our code for this analysis. So to begin with, we're going to pull LXML. So we're importing HTML, which is the file type of our Dortmund data bank that we would want to be pulling the data from. Well, it's the file type of this Flash disabled version of the Dortmund data bank. One of my professors has created this Flash disabled version of the website to allow me to scrape the data without having to reload this data page and everything that goes with it for each data point that is being pulled out. When you're doing this, when you're scraping the data directly from the website, it can be viewed as a cyber attack on the website from their security system, as if you're trying to dox the website and overload its servers. So they can disable your access, and to avoid that, there's this flash-free version of the website provided by the professor. And you can see here that we have data corresponding to the data in this table. So that this is the temperature followed by the pressure all the way down the table. Temperature and pressure, and they match. Next we'll still want to be up here to keep all of our imports together. We're going to import requests to allow us to request that website from the to request Python to pull that website into our file and pull all the data. Jax numpy, and numpy. These are all libraries of Python operations. Like I mentioned before, they're a lot of math operations that'll help us model this properly and compare the model to the data points. And then for jax.numpy and numpy, we're changing the variable name to call on these libraries to reduce the clutter. Rather than typing out jax.numpy and then accessing that database, we would just type in JNP to keep it simple and easier to read through. Jax is already short, so there's no need to do it there. We're going to import from scipy.optimize. We're importing a minimize function. So then this is how we're going to evaluate the difference between our model and the data points. How well we can fit these together, minimizing the difference, minimizing the error. This allows us to make a plot and add our figures onto the plot for a visual representation of what we will the calculations we'll be doing. Plotly.io is the functions we'll need to add our data points to the plot. And PIO is just a shorthand, it's just an abbreviation for it again. And then we want to import the key from collections. The key is a type of list, but opposed to adding every value into the list, and we would have to add it in order. A key allows us to open both sides of the list and add values from either side, making the computations much quicker and require much less power. And there was, for this analysis, we want to increase the standard precision of Python. So from jax.config import config I tried to go on to another line. And config.update, we're going to increase jax. We're increasing the precision of our Python code, allowing it to hold twice as many points after the decimal. We set it to true. Now I can proceed. Oh, I missed the N. Wait. There's where I missed the N. Alright, and it worked there. And you see how there was an error pop-up message is how it will display errors in the code, and there's no error pop-up message because it was corrected and no more errors being observed. So next we would import our URL. So here I'll have the original URL, which is equal to, this will be the URL of where we are trying to scrape the data to pull all of our data points out of this Dortmund data bank. And this is the website that we are trying to pull it from. So I'm going to copy and paste that in there. And then to avoid that error that I talked about a second ago, we are going to actually be using this site to scrape our data. So I'm going to upload that one as well. Since this is the actual URL we'll be using, I'll name it URL. And we're copying and pasting that site's URL and saving it as the variable URL. And now we're creating a new variable called content where we use the request function. Get is a command. So we want to pull the content out of that URL and save it as the variable content. And then we restructure the data that is pulled to be in a friendlier orientation for when our function reads through it. The function is it's XPath is our function, and we're performing it on this tree variable. We're setting this tree variable, which is reordering the website that we pulled the data from into a more easily accessible form for our XPath function, which I am going to enter next. But before we go to that, let's make sure that this is working properly, and we're getting an error. Request is not an option. Is it requests with an S? Okay, it was requests with an, I neglected to add this S at the end, so I received an error, but it's working fine now. So now we have taken this data from our URL and reordered it so that it's in this readable form for our XPath function. And now we're going to take our XPath function, and first we're looking to pull the temperature data out. So T strings, and it's labeled strings because that's the file type of the data that is being pulled from the website. It's being pulled as string data type. So strings is equal to tree.xpath, and this will run the XPath function on our variable tree